This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 119, we learn about what is new with Ansys Rocky and review news and events from the world of Ansys. Welcome all. I'm Eric Miller, your host on these podcasts and one of the owners here at PADT. And speaking of being here, June is here in Phoenix. I'm recording this on June 6th, and we have had our first day over 100 degrees, and it's happened late this year. So we can't really complain, but I will. And this week is cooling off. So good news for us here in the desert. Even though the pandemic's response has been mostly behind us for a bit, I think we all kind of liked, me personally, like living in our various virtual caves. But I'm starting to see a change. We're seeing more of our team here in the Tempe office coming in more often to work, and more customers coming in to visit PADT. And we're able to get out and visit people even more because, when we go to visit, they're actually in their office and not at home. That's one of the things we've noticed as we've traveled around the country as well. I'm working from home, so I can't meet with you. So it's now I have to admit, most of us chose a career in simulation because it mostly involves working by yourself in front of a computer and not having to interact with other humans so much. But I have to say I've been enjoying the increase in interaction that we've seen lately. And it's been really good. And hopefully we'll get to meet some of our listeners out there as we get out and about at events and visiting customers. We also had our PADT company meeting last month. We do that twice a year, and a good chunk of people, largest since before COVID, were able to be here in person, about 60 to 65. I think at the end it was around 65 folks of our 90 or so employees were able to make it. And if you're curious about what we look like in our we had these really cool light blue shirts that we got with PADT logos on them for the guys, and these dark gray, almost black shirts for the female employees. So if you want to see what we look like, about 60 of us, you can go to www.padtinc.com, then click on About Us, then on History. Then in the little history section, go to the bottom tab. It's called A Revitalized Team. And then scroll to the bottom of that section for our 2023 picture. So it's worth the clicking. I think we all look pretty sharp out in front of the PADT building here at the ASU Research Park in Tempe. So I bring it up because I'm very proud of the group of people that work here. They do amazing things. They're fun to work with. They're smart. They're humorous. And I kind of want everybody to kind of know what they all look like and feel a little bit closer to us, even if it is in a virtual sense. So moving on to our interview, I'm very excited about today's episode because we're going to talk about Rocky, which is just cool. And if you're not familiar with the code, you'll learn why. We've talked about Rocky before. It was written by a channel partner in South America, ESSS, and then Ansys was distributing it, and we were happy to be part of that. And then Ansys just decided to go ahead and acquire the tool from ESSS, and so it's now officially part of the full Ansys family. And what that means to you as users is better integration with other tools, as well as a faster pace of adding capabilities and features. But let's hear from the Ansys product manager of the Fluids unit in order to find out more about Rocky. I want to welcome everybody to our discussion today about Ansys Rocky. I'm joined by Jeremy McCaslin, who is joining us on our podcast today to talk about this really, really cool tool that if you've listened to the podcast, I'm a huge fan of. Welcome, Jeremy.
Thanks, Eric. Really appreciate being here. Thanks for the invite.
Yeah, I really want to learn about the tool for those that don't know about it, and then get an update on what's new for those that have looked at it in the past or use it. But let's get started with a little bit of focus on you. What is your background? How'd you become a simulation person? How'd you get in the world of simulation?
So I am coming to you guys today from Costa Mesa, California. I work for Ansys out of our Irvine office, and my house here in Costa Mesa is about 9 miles from the office. And so I split time between my home office and the Irvine office. So I guess a little bit of background about me. I got a bachelor's degree in physics from a really small liberal arts college named Covenant College back in 2008. Mm-hmm. And then I decided that I really wanted to do a little bit more hands-on stuff. The physics world was fun, but I got a little tired of talking about particles and boxes and things like that. So I went to University of Colorado at Boulder. My family was all in Colorado at the time, and I love the snow. I love to snowboard, and I
Yeah.
thought, hey, why not go to grad school somewhere, near the Rockies where I can get up there on the weekend. So I was at CU Boulder, and I did a master's in mechanical engineering. And it was my fascination with flight that drove me towards fluid flow. And so I started out working for a professor in a wind tunnel doing some
Right.
measurements. And then eventually I got linked up with a professor that was more on the simulation side. And so that's kind of how I got connected into fluid mechanics, specifically the computational side of fluid mechanics. So I finished my master's at CU Boulder, and then I went to Cornell University in Ithaca, New York, where I did my PhD, also in mechanical engineering. And that was where I got very heavy into the CFD and worked with a group where we wrote our own code.
Right.
And I specifically, my thesis was developing techniques, numerical techniques to track the free surface between liquid and gas flows. So that was my area of expertise and my specialty. Joined Ansys right out of grad school. On the ACE side, that's our Ansys customer excellence team. So I was an application engineer. I did that in various roles, post-sales support, pre-sales support, consulting, did a bit of flavor there for about 4 years. And then I joined product management in 2019. And that's where I've been ever since. And, so I look after the fluids product line as a whole. And that's where Rocky kind of rolled in. And it's a little bit misleading. We talk about Rocky, and I'm sure we'll get into that, but Rocky's much more than Rocky's not fluids, right? It relates to fluids, rolls up under my product line, and it's been a blast. And I've been super impressed with the team, with the Rocky team, and the software itself. So that's been a lot of fun to kind of add to the portfolio and to have the privilege of being the person looking after Rocky.
Yeah, that's fantastic, and you're right. It's for those people like me that I'm a structures guy. If it's not solid, I consider it fluid. So, we'll throw it there. Or if it's not a field, right? It's not a field, or it's not a solid. We'll call it a fluid. So I get it. So let's start there. For those that are not familiar with what Rocky is, it's a different kind of solver. It solves a different kind of problem. Let's get kind of a high level overview of what that solver is.
Yeah, sure. So Rocky is really this will be fun, but what you could call it many things. You could call it a discrete element modeling tool. There's a field of computational engineering out there called discrete element mechanics or discrete element method. And Rocky falls into that category, right? It's not a continuum structural solver like a finite element solver. And it's not a continuous fluid solver like a finite volume or a finite difference solver like Fluent is or CFX is, right? So it's a different umbrella of engineering tools. And that umbrella is really called discrete element modeling. And the key word there is discrete, right? So we're talking about discrete elements, things that are not contiguous, right? Like I've got a rock over here and I've got a rock over there. They're not touching each other. There's space in between them, right? They can move towards each other. They can move away from each other. They can collide with each other. They can break one another, right? So it's kind of like a pool balls on a table, right? When I'm playing pool, well, as I shoot the pool balls, right, they're moving through fluid. There's fluid around them. The air in the room is the fluid around them. If I zoom in on one ball, that itself is a structure, right? And if I look on a small enough scale, like if I'm the size of a pea compared to that pool ball, then all of a sudden the ball is pretty big, and that's a continuous solid structure that's much larger than me, right? If I'm in the reference frame of the pea. But me as the person playing pool, these are discrete objects. They're nowhere near the size of the pool table or of the floor that I'm standing on, right? So when we talk about discrete elements, they could be treated as discrete for a number of reasons. And one of the main reasons is what's the length scale that we're looking at? What's the length scale that we're considering, right?
Okay. So that's a really good overview, and I think it really helps us understand that we're dealing with these particles. I think of it as ping pong balls. I think pool balls, things like that, interacting with each other. And let's talk a little bit about why we use this method. What kinds of problems is it good for solving that maybe the other methods we talked about, like the finite volume, finite difference, finite element, aren't a good solution for?
Sure. So one thing at first I'll say is
Mhm.
when we say particle, we do have to be careful, right? Like
Mhm.
when we did the acquisition recently and we were drafting the press release, one person read it and said, you know, when we say particle physics, I think of Big Bang Theory, right? And so, coming from a physics background, that's very true. Like there are
Yes.
people out there called particle physicists. There's a branch
True.
of science called particle physics. That is not what we're talking about with Rocky. And so the word particle is kind of a misnomer, which is why I like to use the words discrete element. But that's,
Okay. Yeah.
to the layperson, they're like, what the heck is a discrete element? So
Mhm.
it gets a little tricky, the language, you got to be careful. But when I will say element and particle kind of interchangeably,
Okay.
but Rocky, one of the really awesome things about it that differentiates it is it has, it can do what we call shaped particles, right? Like a particle can be any arbitrary shape that you can think of, right? Like you can very accurately represent a banana or a gummy
Okay.
bear or a stalk of corn, right? These things could all be particles in Rocky, right?
Mhm.
My camera's off, but I said that with air quotes, right? Like it's a discrete object. It can have any shape you want, any arbitrarily complex shape, and Rocky can model the shape of that object, right? And it can model multiple of those different together in the same environment, coming together and colliding, right? And so
Mhm.
there are lots of really interesting applications for it. So like, for example, if you're, let's first talk about use cases that are relevant to the traditional Ansys user. And I'll
Right.
focus on what we would call our flagship users, people doing
Mhm.
Ansys CFD, like using Fluent, or
Mhm.
Ansys structural users using Ansys mechanical, right?
Right.
So if you're, just think of large companies that make heavy machinery and agricultural equipment or
Mhm.
mining equipment, right? Like Rocky came from the mining industry in South
Right.
America. That's why it's called Rocky.
Ah.
And you have these heavy duty things that scoop up gravel and rocks, right? Earth movers. And
Mhm.
as that bucket loader is scooping through rock and gravel, it's going to experience structural load, right?
Mhm.
It's picking up heavy equipment. Is it going to break? How long is that bucket loader going to last? There's actual structural damage happening to that thing. And so Ansys Mechanical can
Mhm.
account for the loads on the bucket loader itself in this example, but it cannot account for the rocks and the gravel that the bucket is scooping through and picking up. And that's where Rocky comes in. So Rocky can model the motion of all of those different sized rocks and debris and gravel that's being
Mhm.
scooped up. And the actual, the weight of gravity of those things and the momentum of them bumping into the bucket loader causes forces to be exerted on the bucket loader. And so Rocky talks with Ansys Mechanical to transfer loads from the rocks to the bucket loader and back and forth. And so Mechanical is covering the bucket loader and solving for the stresses there. Rocky is accounting for the motion of the bulk material of the rocks and of the
Mhm.
gravel, right? And another good example on the fluid side
Mhm.
would be like a fluidized bed reactor, right? And if you have if you have if you have a bed of material, a bed of particles, and you start shooting fluid through it, this interesting thing happens that we call fluidization, right?
Right.
And I like to give people the example of you're walking on the beach, you bend down and you scoop up some sand into your hand, right?
Mhm.
And then you open up your fingers a little bit and the sand just kind of falls through your hands. Like, is that sand? Is it a fluid or is it a solid,
Right.
right?
Right.
It looks a heck of a lot like a fluid, right? But if
Mhm.
you zoom in, each little granule of sand is a solid particle, right? And so solid objects can behave like fluids when you fluidize them. And so a fluidized bed reactor is a bed of bulk material and we shoot fluid through it. And you do all sorts of interesting, you know, biochemical reactions and combustions inside of that chamber. And in some instances, all of those granular materials, maybe they're all spherical and they're all similar shapes and sizes. And so you could get away with using a different approach, all intrinsic to a tool like Fluent. You could use like a dense dispersed phase model or other approaches. But if you're looking at a lot of biochemical applications, that could be mulch, they could be wood chips in there, and they're all different shapes and sizes. And you're not going to get the fluidization behavior properly unless you account for the different shapes and sizes. And you can do that in Rocky. And so Rocky would couple with Fluent in that instance, right?
Perfect.
Yep. So that's a classic example. There's all sorts of others, right? Like if you're driving a buggy, like an off-road vehicle around, in the high desert here of California, you're driving this thing over rocks and sand and all sorts of hay. There's a serious issue where you can actually collect debris in certain parts of the undercarriage of the vehicle, and you can cause a fire to happen, right? So
Gotcha.
In that case, you've got the airflow over the car and under the car, coupling with Rocky to account for the presence of these of all this different debris that's being collected underneath the car. And Rocky, keep in mind, literally a fiber, like a strand, a flexible fiber, Rocky can treat that as a particle, right? So Rocky can model anything from like I said, gummy bears to hair inside of a pet vacuum cleaner, or hay being caught under the debris as part of the debris under your car. So it's an incredibly vastly applicable tool across all sorts of different industries. So those are, I was trying to give you a flavor for how it adds value to, our core flagship products.
Yeah, that's a good overview. I guess one really big question that I have is that multi-physics question. So what does Rocky couple with? So I can model my discrete objects, and I do think of potato chip modeling sometimes when I'm hungry. But I want to know what the load is on the conveyor belt or the hopper or whatever that is, or maybe I'm blowing on it with the Airstream to separate out things. So can I do that sort of thing?
Yeah, absolutely. You can. Really quick, since you mentioned chips, right? We do have a really cool example, and this was, it's in the public domain with PepsiCo, and they literally have potato chips inside of a seasoning drum, right? And this thing is rotating, and I mean, you're like, well, why are they simulating that? Well, imagine you bought a bag of chips and you reach your hand in, and maybe they're barbecue flavored or whatever.
Right.
You grab a chip and there's no flavor on it. And then you grab another chip and it's like, holy cow, your mouth's overwhelmed because all the barbecue flavoring was on that chip. Or you reach in and all the chips are broken. It's a fresh bag. You expect crumbs at the bottom, but
not all.
So this is actually this is a packaging and manufacturing issue where Rocky adds major value. You can simulate these 2D shells as particles in Rocky, rotate them around in a drum, and optimize the seasoning, the design of the drum itself and the actual process. And that instance, you could do that all with Rocky. You wouldn't have to couple it to anything. But the tools, I think specifically your question was, what are the Ansys products that can couple to? Is that right?
Yeah, exactly. Yeah.
Yeah. So you can couple it to Fluent. You can couple it to Ansys Mechanical. It couples with Ansys Motion. It couples, and then it basically has Workbench plugins. So imagine your typical Workbench setup. You've got Fluent and Mechanical. Well, you can drag Rocky in there. You can connect them all together. You can have Motion in there. It works with OptiSlang, so you can do optimization in Rocky with OptiSlang. So it's very deeply integrated into the portfolio.
That's one of the things I always really stress with folks is when Ansys brings in a new tool, it just doesn't sit on the shelf. It gets put in with everything else. So very, very pleased to see that. So I want to dig deeper, but people won't listen if we talk longer than like 30 minutes. So we'll move on to the next question because I'm just fascinated by the physics of it. I guess so we've kind of talked about the basics and how it's used and so some great applications, So when did the acquisition happen? So our friends, for those who don't know, our friends down at ESSS are the second best channel partner in the world after PADT. They wrote it, and we're huge fans of them, and we're always huge fans of Rocky. And then recently, how long ago was it that Ansys acquired the tool from them?
We acquired the tool. The deal closed towards the end of December of last year. So just
okay,
5,
so very
6 months
recent.
ago. Yep.
Okay, very recent. So that it was working, of course, with Ansys and in the Ansys world, and then you guys acquired it. And so after the acquisition, what that you can share with us, what's been updated on the code and anything about future direction that you can share?
Sure. So like you said, so the ESSS guys, fantastic partner, and like many of our channel partners, they recognize, sort of, let's say, a hole in the portfolio sounds bad, but that's essentially what it was.
Yeah.
They created a tool that, as a reseller of Ansys, hey, here's something else that would add value to that portfolio that we can sell alongside of the Ansys brand that we sell. And so Rocky was created it really was created with Ansys coupling in mind from the get-go. And that's why, even before we acquired them, it had all of these couplings with the Ansys portfolio. And so it was a very natural fit. And since the acquisition, we've been trying to do our homework to understand what are the ways that it couples with the Ansys portfolio, and how can those couplings be improved, right? Like, for example, Ansys and Rocky and Fluent coupled together in many different scenarios, like we've started only barely discussed.
Yeah.
And all of that coupling happens through user-defined functions in UDFs.
Right.
User-defined functions in Fluent. And so we have a tool called system coupling that really is for, mapping field quantities between solvers back and forth together. And so system coupling would be the natural way to couple these together. But back when Rocky was first integrated with Fluent, that wasn't really, for whatever reason, the system coupling route wasn't gone. It might have been a timing thing. I'm not exactly sure. It kind of predates me, but that's an obvious one, right? Is we want to be able to couple our flagship CFD solver and Rocky with the best coupling methodology that we have, right? Exactly. And so that's something that we're actively working on right now. On the mechanical side, it's the same thing. They already had some system couplings in place, but it was really only on one-way coupling side, and so we want to get two-way coupling there. And then another big, I would say, synergy post-acquisition is bringing Rocky into our pervasive insights plans. And I mean, we could do a whole nother podcast on what the heck is pervasive insights at Ansys. But what I will say is the developer ecosystem, if you've heard of PyAnsys, we have this effort to basically get, headless versions of all of our solvers wrapped in Python APIs out there in the open ecosystem through GitHub, right? Yeah. And we've made great ground. We've made we've delivered along that roadmap substantially. We have PyFluent out there. We have PyMAPDL out there. And so PyRocky is something that we want to deliver. We want to be able to deliver, the Python. And one great thing about Rocky is it already has a Python automation API around it. So it's, delivering PyRocky is going to be a much lighter lift than, PyFluent, for example. But it's still, we need to stand it up and get it out there in GitHub. And then, so that's the first step in having Rocky come along with Ansys in the pervasive insights journey.
That's really encouraging. Yeah.
And then more from just like, let's say a core software architecture and, informational, like best practices of software development perspective, Rocky brings so much to the table, right? Like it's built on C++ and Python for automation, and it uses, modern graphics toolkits. Like it's just a very powerful modern software from a software development perspective. And I'm not a software engineer, so I can't really say exactly what those things are, but you just, fire up the tool and use it, and you can feel what I'm talking about. Right. And so there's a lot of best practices from Rocky that can be shared, cross-pollinated across Ansys development teams. Because we have a lot of tools that have been around for a very long time. Which is just fantastic because we have all that experience, but there's always room to improve and modernize software development practices and things.
So true. So true. The core Ansys solver is still, on the structural side is still Fortran. So it's, older. Yeah, it was mature when I started using it 30 some years ago. Very cool. What about hardware? Is this something where you need like a super duper set of computers like you would for a big Fluent run? Is it kind of like a big mechanical run? What kind of compute power do you need to run? I know it depends on the job, but
yep.
Let's say I'm scooping rocks with a front end loader. What kind of a computer am I need for that?
Yeah, that's a great question. And like you said, I mean, the main thing is really going to be the size of the problem, right? And so in the mechanical or Fluent context, what that means is how big is the mesh, right?
Right.
Rocky being DEM it's what we would call a meshless method, right? Like there is no continuous mesh. So when we talk about problem size, we're talking about how many particles, right?
Okay.
How many particles? What's the faceting required to represent those particles, right? Like if you have a bunch of spheres, well, you can resolve those. The surface resolution to resolve a sphere isn't super high, but if it's tablet compaction and these are tablets and you need to capture the shape properly, well, you're going to need more points and polyhedral element types to represent those particles. And so it depends on how many of the element that you're looking at and also the shape of the element. And that will dictate the hardware. And what you need is, so another great thing about Rocky is it is platform independent. So it runs on CPUs and it runs on GPUs. But what I will say is, it really was designed and optimized for GPU consumption. So you're not going to be overly impressed with its performance when you run it on CPUs. When you run it on GPUs, that's where it really shines. And so, if you've got a laptop that you bought within the past decade, let's say within the past 5 years, whatever GPU it has on it, Rocky is going to run on that GPU. And the performance that you get will depend on what are the specs, right? Like every GPU has a certain amount of VRAM associated with it. So you have to make sure that you don't exceed the RAM on the card. And so really it's a matter of how big is the problem. And if you're trying to do, like let's say 100 million particles and you're looking at some, pharmaceutical process, right? Then you're going to be running this thing probably on a server somewhere, making use of Tesla architecture NVIDIA cards, V100s and A100s, right? Most of our users that are doing, let's say, industry strength Rocky simulations, they're running on V100s and A100s.
Okay.
It is limited. I will say it is limited to NVIDIA today.
Right. Yes. Yeah.
And as part of, going back to your question about acquisition, we are, in the let's say on the discovery and on the Fluent context where we have this GPU solver for fluid flow, that's NVIDIA compatible today, but we already have a prototype working on AMD. We want to be able to do Intel cards as well. And so that's one thing we want to add to Rocky is we want to be able to make that NVIDIA only GPU code. We want to be able to have that run on other graphics cards as well from other vendors in the future.
That's good to hear. Yeah, unfortunately, the Bitcoin miners have moved on to their own custom chips so that you can actually buy GPUs now, which was a bit of a problem there for a while.
Yeah,
sucking up all the inventory.
We had an application engineer, kind of tongue in cheek, but sent out an email saying, "Hey, look what I found on eBay," and it was he found a DGX, an NVIDIA DGX box on eBay.
Yeah, they moved on to their ASIC. Yeah, that's funny. Well, okay, so covered all the hardware and the software, and this is just like any other Ansys product, right? So if you're interested in learning more, you can go visit the Ansys website. I assume there's some stuff in the Learning Hub
Yep.
on it. Okay.
Yep. We've got there's a Rocky classroom. Do we call it or what? Yeah. There's dedicated Rocky material on ALH. Yeah.
Okay. Great. Excellent. And so they should just reach out to whoever they get their Ansys from, and maybe get some Elastic licenses and or token. What do we call them? Elastic. They keep on on changing the name of them, but
the Ansys,
Ansys
the
Elastic
ACs,
Units,
Elastic
yeah.
Currency.
Elastic Currency, yes, Elastic Currency, and you can try it out, or if you just need it every once in a while, and search the YouTube as well for some really cool videos that have been out for a little while that kind of show. I highly recommend that. They show what you can do with this tool, and it is for those of us that have been trying to do this kind of simulation for decades. It's amazing what you can do. We did a coffee bean roaster about 15 years ago, and ended up doing it at LS Dyna. With spherical they were spherical beans because that was easier, and it was a nightmare. And now that's something you could do very quickly in Rocky. So it's pretty cool.
Yeah. It's there's definitely LS Dyna and Rocky are similar in that they're these really extremely powerful tools that have a capability set that allows you to, I mean, almost anything you can think of. If you were to pair Rocky or Dyna with one of our other products, you can simulate it, right? Like, I mean, babies pooping in diapers, right?
Exactly right.
Sounds a bit obscure. I've seen simulations of that.
Exactly. It's true. It is. The limits are almost gone, and with the addition of Zmax and some other new tools, it really is wonderful. We almost never say no, we can't do that. The two questions we used to get a lot especially from our national lab customers, were lightning and basically big piles of rocks, right? And we can use Delcross to do the lightning, and we can do the big pile of rocks with Rocky. So we don't have to say no to those anymore. It's kind of cool.
My roommate from grad school, shout out to Professor Jesse Capisolatra at University of Michigan. He man, if I had a nickel for every time we'd be sitting around the apartment, he'd say, "We should simulate that," right? All the time that phrase came out of his mouth, and that's one of the things I love working about Ansys. You can simulate pretty much anything. Yeah,
we can do it now. It's amazing. I love it. Well, this has been very useful. Hopefully we can get you back on in the future and talk about other fluids products. Sure. And really appreciate your time, and hope you enjoy the rest of your week. Thanks a lot.
I really appreciate the invite, Eric. This was a pleasure. Thank you.
Okay. Thank you.
So as you can see, this tool opens up a whole class of simulations that we just didn't try to do in the past. I don't know about you, but being able to simulate a pile of rocks is just cool. It's just one of those things when you think about the math behind it, it's pretty exciting, and a real advance in simulation. And we hope to see more and more applications, people use it in ways we didn't think of. It's just cool. So we highly recommend you check it out. Contact PADT if you're lucky enough to be one of our customers. And if not, whoever you get your Ansys from, please reach out to them. As I think I mentioned in the interview, this is a great tool to try out with some of the Elastic things, and Ansys Cloud and stuff like that, so you can really see how it works if you've got an application that it fits for. So for today's commercial break, I want to talk about webinars. Although I'd like to think you listen to this podcast because you find my voice so soothing and inspirational. But we all know you listen to this podcast because you want to learn more about Ansys products and what is going on in the Ansys world. But we just scraped the surface in our interviews here. If you want to dig deeper and delve into what is new in various Ansys products, you should, or learn about Ansys products you're not super familiar with, you should check out our webinars on a service called BrightTalk. Over 5,300 people subscribe to the PADT channel on BrightTalk, where they can find over 125 different webinars, and about 100 of those are on Ansys-related topics. They're given by the same experts we have on the podcast that come from Ansys, for PADT's Ansys support team and consulting team. We talk about new features or how to use the tools better. It's free, it's easy, and we keep seeing more people subscribe to the channel, which must be a good sign. I think what sets our seminars apart is that we're not just reading through slides that we get from Ansys, right? We use those slides and we kind of redo them, and we add what we think as working engineers is important and what you really need to pay attention to and how it can affect your job. So check it out on brighttalk.com and search for PADT. So you go to brighttalk.com and search for PADT. Or if you don't want to do that, you can just type padtinc.com/webinars into your browser, and we'll go ahead and redirect you to the channel on BrightTalk. And don't forget to subscribe. You will get a notice when we add a new webinar if you do that. So please enjoy. Let us know what you think. let's go ahead and move on to news. We'll start with the Ansys stock. Well, the market is generally doing better, and so is ANSS, the Ansys stock. Before the market opened, when I looked this morning on June 6th, they were at $327.86 per share. That puts the market cap at over $28 billion. That is 26.88% increase from the time 1 year ago that the price has gone up 26.88%. And the S&P 500 for comparison over the last 12 months has only gone up 4%. So Ansys is outperforming the broader market. The price is just short of the high this year of $332, but still not up to that just north of $400 that it was before things kind of slowed down. What we have not done is look at their Q1 financials. And so I did that. I apologize. Here we are in the last month of Q2, and we haven't looked back. So let's go ahead and take a closer look. And well, it was a good quarter. Revenue of $509.4 million in Q1. So that bodes well for doing $2 billion for the year. A profit margin of 25.1% on a $100 million profit. So even I can do that math, 500 million, 25%, 100 million profit. And they had a record Q1 annual contract value of $399.4. So that's contracts they sold that go out into the future. And a new number for me, it's probably been there, but I didn't recognize it before. It's called the deferred revenue and backlog of $1.357. So that's the commitment from customers to spend money with Ansys. These are contractual commitments. So that's revenue they're deferring or backlogs they have on the books. So that's a lot of money that if they don't add anything, they'll get. So year over year, Q1 to Q1, revenue was up 20% and profit was up 42%. So that's good news for those of us who want them to spend more money on R&D. That profit allows them to either acquire people or hire more engineers. So cash on hand is down a bit to $508 million, and long-term debt is the same place it was before at $754 million. So a strong start to the year and a lot of long-term contracts in place. So pretty healthy considering the uncertainty in the market today. It's good to see it. The people that we care about selfishly are the developers who hopefully will get paid and will keep adding great capability and fix bugs. So good stuff. We'll take a look at Q2 when it comes out the first half of the year in a couple months. So in the world of news, the big news is that Ansys made another acquisition. They bought a company called Diacopto. I think I'm pronouncing that right. The bad news is I have no idea what they do. It's a chip simulation tool. I've never heard of it before. I think it fits within the product family. That's the Apache product family. And looking at the press release, they actually say the acquisition complements Ansys's existing sign-off solutions and enables integrated circuit designers to detect problems early in the design flow. So this is when you're designing your big, massive integrated circuit chip, and you want to make sure all your transistors are lined up right and all your stuff is in the right place. And you use this tool to do that. So very sophisticated, very high end, and must do something that we didn't do before. So if you're in that space, you're probably pretty excited about it. There was only one other interesting news story that just came out, and I thought it was cool because if you're like me, you kind of grew up reading about how shark skin reduces drag, right? The way that the pieces of the skin kind of tile on top of each other, it creates a more laminar flow over the surface of the shark. And it turns out that somebody at Lufthansa, a company called Lufthansa Technik, which I think is their engineering arm, used Ansys to figure out where to put a coating that uses the kind of shark skin idea. And the idea there is to place it in places that need more laminar flow, which therefore reduces drag, which depends on how you look at it, reduces emissions, which is good for carbon reduction, or reduces the cost of gas for a flight, which increases their profit. So it's a win-win either way. So thought that was really cool. Great use of Ansys, and worth a read to kind of dig into that deeper. We don't have any news from PADT. Nothing going on here worth talking about. On the Ansys blog, it's been over a month since we took a look at the Ansys blog. So there's been a lot of articles. So if you don't regularly check out the Ansys blog, I recommend you do. They're really getting, they're getting bigger. So they've got more people submitting content because they have so many different products. But they've made a real commitment to content creation. And so they're doing some value-added writing. So you should check out the Ansys blog pretty regularly and see what's there. So my 3 favorite articles since the last time we talked, which was a little bit over a month ago, is a company called Hermeus. Disrupts aviation at hypersonic speeds with Ansys simulation. So they're developing a hypersonic engine, I believe, and they're using Ansys to figure out how to do that. And if you know anything about hypersonics, these are shock waves at very, very high speeds, a lot of energy, plasmas, all sorts of crazy stuff. An area, a lot of temperatures, a lot of big temperature gradients. So great application for Ansys. And we have some customers that are doing that as well. And love to see the growth in that area. Also, they covered the Space Symposium, which if you listen to the podcast, we were at in April. PADT was in the Arizona booth. And Ansys, of course, was there with the folks from what used to be AGI. And so they wrote a really cool article, Space Symposium 2023, Mission Accepted. And it kind of parallels some of the things I said in an article I wrote for the Phoenix Business Journal here about space is, pun intended, taking off. It's no longer about how we're going to do something or when we're going to do something. It's about we're doing it and we got to figure it out. The people have launch dates for their products. It's not planning anymore. So there's just a ton going on in commercial, in military, in exploration, government paid exploration, stuff going on around the world. It's not just the US and the EU. It's really cool. So if you're a space geek of any kind, or definitely read that article and follow along with what's going on in that space. And then the last one is, again, an aerospace related one. We're kind of aerospace heavy this time. It's hybrid electric propulsion, a new era in aviation. So we're seeing people look at using electric propulsion on aircraft. And it's hybrid in that the electricity can be created in multiple different ways. It can come from a battery. It can come from some sort of a generation source, maybe a more efficient turbine engine that's generating electricity. There's all sorts of hydrogen. There's all sorts of ways to do a hybrid. It's kind of like your hybrid car, like my Prius, right? So check that out. Yeah, I think in our lifetime, at least my lifetime, I'm not that old, I'll take a short hop at least on an electric airplane, which will be kind of cool. So less carbon and hopefully quieter. Let's hope that's part of it as well. Then on the PADT blog, well, we've been really busy. We haven't really published anything that's Ansys related. There's a couple articles on Flownex and 3D printing, so do check those out if you're interested in those things. But our staff has been busy supporting customers and hasn't had time to write anything. So I am working on an article about PyAnsys that I hope to have done by our next podcast. So hopefully by putting it out there, that'll get me motivated to finish that project. That's pretty much it for news and publications. Upcoming events. Let's see what's going on in the world of PADT event-wise. So I'm just bringing up our events page on the PADT website. So hopefully you'll get this before this one, but since it's on Bright Talk, you can always listen to it after it's recorded. But our very own Jim Peters, who's a frequent contributor to the podcast, will be doing LS Dyna updates in Ansys 2023 R1. Even if you're not an LS Dyna user, I recommend you listen to this webinar. We're using LS Dyna for stuff we didn't use LS Dyna for 5-10 years ago, right? It was mostly explosions and crashes, which we still do with LS Dyna, but we're doing all sorts of other stuff. More metal forming, more manufacturing processes, modeling biological systems, stints. There's just a lot going on in Dyna that it is really expanding our ability to do simulations. So definitely check out that webinar, even if you're not already an LS Dyna user. And if you are an LS Dyna user, you definitely need to hear what Jim has to say about what's new. Then upcoming at the end of the month, we're going to be at the Turbo Expo in Boston. So it's in the U.S. this year. It goes between the U.S. and overseas every year. It's at the Heinz Convention Center, I guess, in Boston. And we won't have a booth, but we'll be walking around. Now we got a lot of customers there. We do a lot of work there. We'll have some folks in the FlowNext booth. So if you do go to the Turbo Expo, stop by the FlowNext booth and say hi to the people in the PADT shirts that are there. So we'll be definitely representing FlowNext as well as Ansys as we walk around. And then also that same week here in Phoenix, we're a sponsor of and will be speaking at the 2023 E-Mobility and Clean Energy Summit, which is put on by the Arizona Technology Council and the Arizona Commerce Authority. We are focused, NASU I think is helping with this one. We are focused on really talking about the business of electric vehicles, electric aircraft, batteries, alternative energy, clean energy generation, clean energy storage. We're not really getting into water and stuff like that. We're really talking about energy here. So solar, wind, you name it. Geothermal, I think we got some discussion on. So it's really a chance for you to meet all the players in the clean energy e-mobility space in the state and hear what they're working on and talk about the business climate for that kind of stuff. And that's pretty much it until July, when we will be at another Tech Council event. July 13th is going to be the Aerospace, Aviation, Defense, and Manufacturing Conference. That's down in Tucson this year. So Raytheon has been kind enough to be heavily involved this year. So we're going to go down there and spend some time really talking about all of the incredible aerospace stuff, aviation, defense, and space that's going on in the state. And then we're also going to talk about manufacturing. So highly recommend, if you're in the state of Arizona or do business in the state of Arizona for aerospace, you check that one out on July 13th. That's events. That's everything. So I want to thank you very much for helping us out on all this stuff. Don't forget to subscribe at www.padtinc.com/opt-in. Don't forget to subscribe to the podcast as well. That link will take you to our newsletter. The podcast can be subscribed wherever you get your podcasts. And as always, don't hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 119. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.